Now we're going to look at Chapter 2. We'll look at trade-offs, comparative advantage, and give an overview of the market system. In Section 1, we'll construct the production possibilities frontiers. So this graph will show a relationship between the production of two goods in an economy, help illustrate the trade-off that when you want to produce more of one good, you have to produce less of another good because of the scarcity that we face. We'll also explore opportunity costs because this is a way to highlight the opportunity costs of the production of one good over another. In the next section, we'll use the production possibilities frontier and the idea of opportunity cost to explore comparative advantage and when trade can take place. Finally, we'll end this section, or end the chapter, by looking at a section on the market system, give a brief overview of that. So in a society, households, firms, governments, consumers, everyone faces decisions almost constantly about how to best use their scarce resources. Now remember, scarcity is a situation in which the unlimited wants that we have exceed the limited resources available to fulfill those wants. Because of scarcity, we have to make choices, and this requires trade-offs. When you make one choice over another, you necessarily give up the benefit from that other activity. So economics teaches us the tools to help us make good trade-offs, to help understand what's going on, and to make the best choice. So for example, when deciding how to use its scarce workers and machinery, Tesla only has so much able to produce the different automobiles they make. If Tesla wants to produce more Model X SUVs, those resources will not be available to produce Model S sedans. So they have to make a choice. How many Model X's do they want to produce, and how many Model S's do they want to produce? So they can use a production possibility frontier to help them reach the best decision. So in this first section, we'll use a production possibilities frontier graph to analyze the opportunity costs and to explore the trade-offs that firms, individuals, societies face. So production possibilities frontier, to give you a definition, this is a curve showing the maximum attainable combination of two goods that can be produced with available resources and current technology. So along the production possibility frontier line on the graph, that will be the best that a society can do while producing those two goods that we're looking at. And now, production possibility frontier, these graphs are they're a positive tool, not a normative tool, because they're explaining what's going on. It's showing what the trade-off is, not talking about what the trade-off should be or what the optimal combination of those two goods are. We can use our normative judgments once we've developed the production possibility frontier and explored what the trade-off is at different points. So let's go back to our Tesla example. They can produce either sedans or they can produce SUVs. If Tesla wants to produce more sedans, because of the scarce resources, they only have so many materials to build cars and so many workers to actually go in there and build the cars, it has to reduce the number of SUVs when they want to produce more sedans. The top figure on the right shows Tesla's their production choices. So they have 5 different choices, and they have a combination of sedans and SUVs that they can produce. Choice A, they can produce 80 sedans, but if they do that, they'll produce 0 SUVs. At point E, if they produce 0 sedans, they can produce 80 SUVs. And then B, C, and D, they can produce some combination of sedans and SUVs. Then we can take those points and we can plot them on a graph. And that's going to be our production possibility frontier. So if you look, points A, B, C, D, and E are all on a line. They go from 80 sedans and 0 SUVs to 0 sedans and 80 SUVs. And they're connected by a line in between that. Along that line, that is the firm's efficient level of production. So that's when they're doing their best. They can also produce inside the line. So for instance, point F on that graph. But point F on the graph is inefficient because they could be producing more SUVs and sedans given the resources they have. Points to the right of the curve, outside of that production possibility frontier curve, are impossible for a firm to make, or in this case for Tesla to make with their current resources. So in this case, point G, that is more SUVs and cars combined than their resources will allow them to do. Now let's say, for instance, that Tesla is producing at point A on the production possibility frontier. They're producing 80 sedans and 0 SUVs currently. In order to produce 20 more SUVs, so moving from point A to point B, Tesla has to produce 20 fewer sedans. So they move from producing 80 sedans to 60 sedans, and from 0 SUVs to 20 SUVs. In this case, the 20 fewer sedans is the opportunity cost of producing 20 more SUVs. Remember, the opportunity cost is the highest valued alternative that must be given up to engage in an activity. In this case, producing 20 SUVs, you have to give up producing 20 sedans. Now, on the previous two slides, we assumed that the opportunity costs were constant. And that's a pretty good assumption for an auto manufacturer deciding between two cars, or two different types of cars to produce. But often, opportunity costs are increasing. So for instance, we'll have the production possibility frontier, like the figure on the right. So why is this the case? Why are opportunity costs often increasing? It's the fact that some resources are just better suited at one task than another. So the first resources that you switch are the ones that are best suited to switching. So for instance, looking at that figure on the right again, if you're deciding between producing tanks and automobiles, there are some things that are very good at producing automobiles that aren't as good at producing tanks. So initially, moving from point A to point B, you're increasing automobile production from 0 to 200. You only have to give up 50 tanks to do that. These are things that are naturally good for producing automobiles that aren't so useful in producing tanks. Moving from point B to point C, however, we increase the production of automobiles from 200 to 400. We're now giving up 150 tanks, so reducing tank production by 150. So the opportunity cost of producing the next 200 units of automobiles is increasing. It's much larger than the first one, because these resources are less well suited to producing automobiles. Or in this case, they're well suited to produce both tanks and automobiles. So you're giving up basically as many tanks as you are gaining automobiles. So basically, the more resources we already devote to an activity, the smaller the payoff from devoting additional resources to that activity. So initially, when we're producing only tanks, those first few resources we now devote to producing automobiles are going to give us a lot more automobiles than later on as we move on producing more and more automobiles. So we end up with, instead of a straight line for production possibility frontier, we end up with a curve, again, because the opportunity costs increase as we produce more of that product. Not only can we move along the production possibility frontier, like we did from point A eventually to point E for the Tesla production possibility frontier, in the long run, we can also move the production possibility frontier outwards, so we can end up being able to produce more tanks and more automobiles in this situation. And that's represented on the figure on the right by moving from point A to point B. So we've now shifted out the entire production possibility frontier. What this represents is economic growth. So as the economy grows, as our resources increase or our productivity increases, we're able to end up producing more. Now on this slide, we have another example of economic growth, but this one's a little different than our initial economic growth. In this panel, the quantity of tanks that are able to be produced remain unchanged. However, there's now a technological improvement that makes makes it easier to produce automobiles. So while we're still only able to produce 400 tanks if we specialize only in tanks, for automobiles we can now produce 800 if we focus on automobiles instead of 500 as we did before. So we've now got a new production possibility frontier, which remains the same point for tanks, but increases all the way along as we produce more and more automobiles. So many of the combinations that were unattainable before at the previous production possibility frontier are now attainable at the new production possibility frontier. So in this case, there's something going on that makes it more productive or easier to produce automobiles, so we can use fewer resources to produce them, which in essence allows us to produce more. However, we're not seeing a change in our ability to produce tanks. So this is something specific to the automobile industry. So we end up with the production of one good becoming easier, while the other one does not change. So let's make a connection of using the idea of opportunity cost for the real world. So suppose you have a limited amount of time to study for 2 exams. You have your accounting exam and economics exam coming up. So what would a production possibility frontier curve for exam grades look like? Would it be a straight line, so like the production possibility frontier we had for sedans and SUVs for Tesla? Or would it be a bowed outward curve, like the production possibility frontier for tanks and for automobiles that we had in the previous example? It turns out it'll be the second, it'll be a bowed out curve. So the first hour you spend studying for economics is going to be much more valuable, so have a much lower opportunity cost than the last hour. So that the early hours that you begin studying, you'll gain a lot more information than you will in those last hours. And that should make intuitive sense, that the more you study, the less and less you're getting back from those increased hours studying.